Welcome once again to my channel. This time we are going to be looking at post-UTME questions for those students that are preparing to write in the UNIDEL post-UTME examination. That is talking about University of Delta, Agbo. So many students have been on my DM asking me to do series on UNIDEL, and there you have it. Now we are going to be looking at 10 questions, and these 10 questions I would use them to explain exhaustively things pertaining to areas that you can be asked questions. So even when you see a particular question and you know the answer, endeavor to watch the video to the very end, because I'll be explaining other concepts with regards to a given question. All right, so let's start. Looking at question 1, we are told that which of the following quantum numbers defines the main energy level the electron occupies? Which of the following quantum numbers? So the key words here are quantum numbers. Many students, they find quantum numbers very difficult to understand. But the thing is this: quantum numbers are not that very big numbers that are so, difficult to understand. Now, there are about 4 quantum numbers. Let me just go straight to the point. Now, the 4 quantum numbers are the principal quantum number, we have azimuthal, the azimuthal quantum number. The azimuthal quantum number is also known as subsidiary quantum number, or you can as well call it the angular momentum quantum number. Then we have the magnetic quantum number, and we have the spin quantum number. So these are the quantum numbers that we have. The principal quantum number is denoted with the letter N, then while azimuthal is with the letter L, then magnetic is with the letter M subscript L, and this one is with the letter S. So now, considering these quantum numbers, one very important thing that you need to take cognizance of is that these quantum numbers, they give information about location of electrons, especially that of principal and azimuthal. Now, principal is concerned with shells, and azimuthal is concerned with subshells. So take note of that. Now, one thing that you need to know is this: that the shells, they are also regarded as energy levels. Is that you call shells energy levels, or you call them orbits. Then as for the subshells, they are regarded as sub-energy levels, or you can refer to them as orbitals. All right. So what gives information about location of electrons in shells is the principal quantum number. So that of the azimuthal, it talks about the location of electrons in subshells. You get the point now. So azimuthal is to orbitals, while principal is to what? Shells. Then for the magnetic quantum number talks about degenerate subshells, talking about degenerate orbitals. When you go through the series of concepts on orbitals, then you get to know that orbitals, we have about 4 types. We have the SPDF, and of which PDF orbitals are degenerate, while only S is non-degenerate. The PDF orbitals by degenerate simply means that they can be split into different parts, such that each part can accommodate equal or equivalent number of electrons. All right, so that's for the magnetic. And also the magnetic gives or describes the magnetic behaviors of electrons, or the behavior of electrons when they are placed in magnetic fields, as well as their properties, magnetic properties. Then while that of the spin quantum number gives information about direction of electrons when they occur in pairs, meaning that when electrons occur in pairs, they move in opposite directions. Something like this. One is pointing upwards while the other downwards, meaning that one is to the clockwise while the other is to the anti-clockwise. So let's see the question. Which of the following quantum numbers defines the main energy level the electron occupies? The main energy level. So talking about energy level, like I said, it's also known as shells as well as what? Orbits. So the quantum number that describes the energy level, the main energy level that a particular electron occupies, happens to be the principal quantum number. So the correct answer is option D. As they had said that which of the following quantum number defines the main sub-energy level, then you should have gone with azimuthal. You get the point now. So that's the answer to question 1, principal. Then let's see question 2. In an electrolytic setup, to protect iron from corrosion, the iron is dash. To protect iron from corrosion, the iron is dash. Then, looking at the options, option A made the cathode. Then B, made the anode. C, used with a metal to lower the electrosulfate 6. Then D, sodium trioxynitrate 5. Now, option C and option D, they are not part of it. So it's not between option A and option B. So how do we get the answer to this question? Firstly, in an electrolytic setup, to protect iron from corrosion, meaning rusting, how do you protect iron from rusting? That's what they are asking here. Now, when you want to carry out the protection of a particular element, let's say from corrosion or from rusting, the thing you are supposed to do if you want to use electrolysis is that you should make the coating metal the anode and make the metal to be coated the cathode, and then endeavor to ensure that the electrolyte, which is the compound you are working with, should be a salt compound of the coating metal. See what I meant? The coating metal, that's what you want to use to cover, should be made the anode. Then the metal to be coated should be made the cathode. Then the electrolyte must be a salt compound, a soluble salt compound of the coating metal, That's for the electrolyte. Okay? So, looking at the question, in an electrolytic setup, to protect iron from rusting, that's corrosion, the iron is, remember I said that the coating metal is the anode, what you want to use to cover is the anode, then what you want to cover should be made the cathode. So, since we want to protect, meaning we want to cover iron thereby should be made the cathode. All right, that's the reason why when you are carrying out what's it called, electroplating of metals using electrolysis, another name for it is called cathodic protection, meaning that you are protecting a particular metal at the cathode. You are coating it with another metal at the cathode. All right, so the answer is option A. Then let's see the next question. Question 3. Question 3. The general formula of alkanones is, so they are taking our minds to organic chemistry. Now, the alkanones, they are present in organic chemistry too. We have the alkanals, we have the alkanones. So never should you mistake the alkanals for the alkanones. The alkanals, they are also called aldehydes. Then while the alkanones, they are also called ketones. So they are asking us for the general formula of the alkanones. Now, for the alkanals, the general formula is ROCHO, while for the alkanones is ROCOR. All right. So let's see the option that best suits that. Option A is ROCHO, which is for the alkanals. So A is wrong. Then option B is somewhat related to this, but wait a minute. Option C and D, they are not part of it because ROCOOH, this is the general formula of alkanoic acids. Alkanoic acids. So when you see any compound that ends with COOH, just know it's an alkanoic acid. Then for this one, which is ROCOOR, this is the general formula of esters. The esters, which are also known as the alkanoids. That's another name for esters. All right, so those two, they are not part of it. So considering this guy, it would make sense that this and this, they are the same, both of them. Why? You can actually just abbreviate this instead of expanding the arrows or repeating the arrows. You can just combine these two arrows to give arrow 2 then CO. So this guy and this guy, they are the same. So hence the general formula of alkanones can be represented using B there. All right, so B becomes the answer to the question. Then let's see question 4. Question 4. A physical change is exemplified by the dash. First and foremost, let's understand what physical changes and chemical changes are. We have physical changes and chemical changes in the initials of chemistry. Now, there are two main stuffs that they usually compare when you are actually talking about physical changes and chemical changes. And what are the two things? The first is are the reactions easily reversible or they are not? Then the second is, are new substances usually formed or no new substance is formed? Let's check. For physical changes, number one is that they are easily reversible. All right, meaning that you can get the product and then use the product to get back the reactant. Then while that of chemical change, it is not easily reversible, not easily reversible. Then for physical change, no new substance is formed. No new substance is formed. Then while for chemical change, new substances, new substances are formed. So a physical change is exemplified by the dash. So let's confirm. Meaning, let's just work with the one that is not easily reversible and whether it is easily reversible. Let's confirm it. Physical change, of course, they are easily reversible. Burning of bush. When you burnt a bush, you cannot get back the bush. So hence, this is a chemical change, is wrong. Then next, rusting of a metal. When iron, let's take a case of the iron. When iron rusts, you cannot get back the previous form of the iron. So that's a chemical change. So it's still what? Wrong. Then dissolution of calcium in water. If you carry out the reaction, when you dissolve calcium in water, you have to obtain what? Calcium hydroxide, which is lignite, with the release of hydrogen gas. This reaction is not reversible. So hence, it is a chemical change. Wrong. Then heating of ammonium chloride. Of course, that should be reversible. The reason is because ammonium chloride is actually an example of a solid that sublimes. And you know what sublimation is? Sublimation is simply the conversion of a solid directly to what? To a gas without passing through the liquid state. So when you heat this guy, it's a reversible reaction. By application of heat, you get ammonia gas and hydrogen chloride gas. But when you cool these two gases, you have to obtain ammonium chloride. You get the point now. So it's a reversible reaction. And remember, physical changes, they are easily reversible. So hence, option D becomes the right answer. So let's see the next question. Question 5. The number of neutrons in deuterium atom is slash R. Now, when we say deuterium atom, we are actually referring to one of the isotopes of hydrogen. Now, hydrogen has three isotopes. We have the H11, which is regarded as the protium. We have the H21, which is regarded as deuterium. And we have the H31, which is regarded as tritium. So these are the isotopes of hydrogen. When we say isotopes, we are referring to differences in mass number. These numbers here, and then same proton or atomic number. These numbers, they are the same. You get the point now. So looking at this guy, you can represent using P11, then this guy D21, then this guy T31. All right. So they are now asking that the number of neutrons in deuterium. So let's focus on the main thing, which is this guy, deuterium. Now remember that when you are given an atom X like this, and then you have A here and Z here, this is considered to be mass number, while this one is considered to be atomic number. So for you to obtain neutron number, you have to what? Subtract Z from A, meaning that you have to remove this guy from this guy. So anything that is written here, you should actually subtract this from it. So it becomes what? 2 minus 1, which is 1. So that's the number of neutrons. What about the number of neutrons in protium? Is what? 0. 1 minus 1 is 0. Then that of tritium, which is 3 minus 1, is what? 2. So that's how you can come up with getting your number of neutrons. So the number of neutrons in deuterium is 1. So the correct option is option B. All right. Then let's see the next question. The next question is a calculation question, and it's on stoichiometry. Now we are given this question. You have to be very, very attentive, because this particular question, most exam bodies, apart from even UNIDEL, most exam bodies, they bring questions on this particular stuff, whereby you are given the volumes of two substances in a given reaction, and then you are told to calculate the volume of a particular substance in the reaction. So how would you go about it? Be very attentive now. What were the two substances? Now, 150 cm cube of nitrogen 2 oxide, very important, were sparked with 100 cm cube of oxygen. So two gases have been mentioned. Nitrogen 2 oxide, which is NO, sparked with what? Oxygen, which is O2. So I'm trying to get the stoichiometry equation. What volume of nitrogen 4 oxide will be produced at STP, meaning we are to obtain nitrogen 4 oxide, which is NO2. So that's how you come up with equations. Then next is the reaction balanced. Of course, it's not balanced, so we have to balance it. We have we can actually make here 2 and 2 so that it becomes automatically balanced. How? 2N 2N, 2 oxygen over here and another 2 here, making a total of 4. 2 times 2 here is what? 4. So everything is balanced. So what is the stoichiometric ratio? This is 2:1:2. All right. So if you have studied Gay-Lussac's law of combining volumes, you tend to know that when you have 2 here, this can represent 2 volumes as well as 2 moles. That's if you are taking your mind to Gay-Lussac's law of combining volumes. You get the point now? Then while this one is 1 volume, this is 2 volumes. So we are given 150 cm cube of nitrogen 2 oxide to be sparked with 100 cm cube of oxygen. Now that you have represented the equation, the next thing to do is to determine the limiting reagent. Now, the reason why you are determining the limiting reagent is because it is the limiting reagent that you are to use to obtain the volume of what you are told to find. So between this guy and this guy, one is limited in supply. All right. So how do we get the limiting reagent? Let's check. From the stoichiometric analysis here, or ratios, we have 2 volumes of NO will yield or will react with 1 volume, will react to 1 volume of oxygen. Then how many volumes of nitrogen 2 oxide were we provided with? We are provided with 150 cm cube of nitrogen 2 oxide to produce what of oxygen, or to react with what of oxygen? Let's get it. That should be when we cross multiply. We want to get the limiting reagent, bear in mind. So when we cross multiply, we are to obtain what? We are to obtain 2x, this will multiply this, equal to what? This will multiply this. That should give us what? 150. So for you to get x, you have to divide both sides by 2. When you do that, you have to obtain what? 75 cm cube. So it means 75 cm cube of oxygen is required to completely react with what? 150 cm cube of nitrogen. And we are giving 100 cm cube of oxygen. We only just need 75 of it to completely react with this guy. So it means we are having this guy to be in excess now, because we need only 75 and we are giving 100. So let's confirm whether this guy is the limiting, because it's obvious that this is the limiting reagent, but let's confirm. Now, still using this stoichiometric analysis. Now, let's now assume that we are not giving anything of this. Let's follow the stoichiometric analysis now. 100 has been provided of oxygen would require what of NO? So using the stoichiometric analysis, when you cross multiply, it becomes what? It becomes x, which is x times 1 is x, equal to what? 2 times 100 is what? 200. So it means that 100 cm cube that was provided of oxygen would require 200 cm cube of this guy, and we are only provided 150 cm cube. So it's obvious that this is not enough, and that is our limiting reagent. So please bear in mind that you have to work with the limiting reagent in order to obtain the volume of what you are told to find. Take note of that. So let's come back. So are we working with oxygen? No, because that's in excess. So we are working with the limiting reagent being this guy. So just focus on this guy and this guy, because we are told what volume of this are we to obtain. So we are just to work with these two, because this guy is what? The limiting reagent. So just bring out these two in terms of their volumes. 2 volumes of NO. We produce how many volumes of that guy? 2 volumes of NO2. Now the question is, what volume of NO2, which is nitrogen 4 oxide, will be produced at STP? So when you are provided 150 cm cube of NO, so this becomes X. F2 produces 2, then this will produce this. You get the point now? So it becomes, when you cross multiply, it's still the same thing. As this times this is what? 300 then equal to what? This times this is what? 2x. So when you divide, you have to obtain what? 150. Or you can just go straight. Two volumes produces two volumes, then 150 will produce 150 since they are the same ratios here. You understand? So the correct answer is option D. All right. So you can actually watch the video over and over again and try your answer on some questions pertaining to this, where you are given two volumes of the two different substances present in a reaction, and then you are told to find one volume of a given substance that is not provided in the question. All right. So the correct answer is 150. Take note of that. Question 7. When calcium carbide, this guy is calcium carbide, that's the formula of calcium carbide, CaC2. When calcium carbide reacts with water, the organic product formed is, you can take your mind to organic chemistry 1 under the laboratory preparation of alkynes. Alkynes. Laboratory preparation of alkynes. When you want to prepare the first member of the alkynes, which happens to be ethyne, also called acetylene, when you want to prepare that guy, what are you supposed to do? You are supposed to work with calcium carbide, dissolving it in cold water because the reaction is exothermic, so it tends to release heat. All right. So when you carry out the reaction, you have to react this guy with cold water, and then you end up producing ethyne gas, and also a minor product which happens to be calcium hydroxide or slaked lime. Like I said initially, that the reaction is exothermic, meaning that it releases heat. So when you are carrying out the reaction in probably a round bottom flask, you know that the flask is made of glass, and when heat is being generated, released to the surrounding, of course, it can affect the glass, leading to cracking or breakage. So when you are carrying out that reaction in the lab, you have to, before starting the reaction, you have to place sand within the flask in order to prevent direct contact of the heat with that of the glass, to prevent cracking of the glass or breakage. And then, of course, the impurity that is obtained is phosphine, which is removed using an acidified solution of copper sulfate. But that aside, let's carry out the reaction. You are dissolving this guy in cold water to produce what? Ethyne gas, which is C2H2, and calcium hydroxide, which is CaOH2. Then, of course, let's check whether the reaction is balanced. One calcium, two the hydrogen. So we just have to make here so that it becomes four. Four hydrogens and four hydrogens here. Then two oxygen over there is two. So this is known as ethyne gas. All right. Because now the question was even being specific. We have two products here, but they said the organic product. So between this and this is an inorganic substance. Why this guy is the organic? So the organic product is actually ethyne. Take note of that. Question 8. Question 8. Consider the exothermic reaction SO2 plus O2 to give SO3. All of them, they are gases. If the temperature of the reaction is reduced from this guy to this, and no other changes take place, then dash. So they want you to go with the one that is correct. Now, they said consider the exothermic reaction. So literally, this guy is exothermic. Normally, they would have done this, but they want students to be confused. This reaction, if they had wanted students to be, to make the question to be easy for students, they would have written it in this pattern, suggesting that this reaction is proceeding in two directions, forward and backward. But now they just represented using just a single arrow because they are only interested in the straightforward reaction, which is the forward reaction. Now, the exothermic reaction. You remember what exothermic and endothermic reactions are? Exothermic reactions are simply reactions that involve the release of heat to the surrounding. So it means that literally exothermic reactions, they dislike heat. So what can favor them is when you lower temperature. You get the point now. But now they said consider the exothermic reaction. Then if the temperature of the reaction is reduced, so it means it is decreased, it is lowered. When you lower temperature, exothermic reactions, they are usually happy and excited. They are happy in that they dislike heat. When you increase temperature, you increase the application of heat. So when you reduce temperature, you are removing heat, you are reducing heat, and that's what they love. So since they only represented the reaction straightforward like this, It means that automatically the forward reaction here is exothermic. And then what can actually make this reaction to be happy? Happy in the sense that more of this will be produced is when you reduce temperature, because this reaction, this forward reaction here, is exothermic. So when you reduce temperature, you will have a high yield or production of this guy. If you want to understand this thing very well, I made a video lesson in this channel. You can do well to check. I made a video on chemical equilibrium, how those Le Chatelier's principle tends to affect it in terms of the factors that affect, uh, you know, changes in equilibrium positions and all that. Talking about the effect of changes in temperature, pressure, and concentration. It's here on this channel. You can do well to just check for it, and then you understand this concept very well. But because of the fact that the reaction is exothermic, what will favor the yield, what will increase the yield of this guy is when you lower temperature. So let's check the options. The reaction rate increases, that's wrong. Concentration of SO3 decreases, which is also wrong. Concentration of SO3 increases, meaning the yield of this guy increases because you are favoring it. It is an exothermic reaction and there was a decrease in temperature. So this becomes the answer to the question. Let's see the next question. Question 9. The correct name for the compound written is, now this is the compound, HCOOC2H5. Now this compound resembles the esters. If it happens to be the esters, not even resembling the esters because of this COO at the middle. So in this case, if you are told to name this compound, I've done a video lesson here where I gave the shortcut on how you can name the esters. All you simply just do just to split into three parts. Now in this case, we are having what? This last alkyl group, you now name it as first, which is ethyl, because this guy is ethyl, coming from ethane. All right, so ethyl. Then how many carbons are we left with? Just one. And one carbon correlates with the prefix met. So this guy should be ethyl metanoate. I gave a shortcut on how you can name the esters. Now, if you have C2H2, or rather C2H5, COO, C2H5, and you are told to name this, it's still the same pattern that we used there. Just split this into three parts from the COO to be at the middle. Then this last, you name it as first, which is also ethyl. And then how many carbons are here? 2. Then you add it to this to make it 3. That's the rule. And then 3 carbons is to what? Prop. So it becomes propanoate. Is that easy? What about if you are given this one? You are told to name this one C4H9, then COO, then C3H7. The same principle, just split into three parts. Then you name this one as first, which is propyl. These 3 carbons, that's why I'm starting with prop. So propyl. Then next, we are left with this and this. When you sum up, it gives 5. And 5 carbons is what? Pent. So it becomes pentanoate. So that's how you name compounds like that. Is that easy? So the correct answer to this question now is ethyl metanoate. So we have it option C, ethyl metanoate. Then question 10. Let's see the question 10. By accurate description, ozone in the reaction, then what happens to ozone? Let's check. Ozone is O3. And then the reaction, what has taken place here? Of course, if you check, this is a typical example of redox reaction, no doubt. But if you should check ozone and oxygen, because now if you look at the options, they are just comparing ozone and oxygen together. Now ozone, the oxidation number of oxygen in ozone here is 0. Oxidation number of oxygen in oxygen gas here is what? 0. So there was no change in the oxidation number of oxygen in ozone and that of oxygen gas. So let's confirm something now about the options. A, displaced to form oxygen. No, this is not a displacement reaction, because displacement reactions resemble something like this to give AC plus D, meaning that A was able to what? To displace D and then pick C to form AC. This is a displacement reaction. So it's not in resemblance with that. Then B, decompose to form oxygen. Let's hold on a bit. Then C, oxidized to oxygen, and D, reduced to oxygen. We can't go with this and we can't go with this. The reason is because there was no change in the oxidation number of oxygen from ozone to oxygen gas. So since there was no change, you cannot say whether it was reduced or whether it was oxidized. But I can as well say it was decomposed, because After this guy reacted with this, it never remained the same, meaning that there was a scattering of it. That was the reason why it was now kind of what, having just two left, meaning that there was a decomposition of this guy. That's the most appropriate in this case, because this guy and this guy is not. You understand the point? Why? Because there was no change in the oxidation number of oxygen. You can do well to watch my video lesson on redox reaction on this same channel. But I've done quite a number of lessons for those new persons that are watching this video. I've done quite a number of video lessons that can be of help to you for those preparing to writing their forthcoming post-UTME examination. So do well to just scroll down and then check other videos that would be of help to you. This is the first series of UNIDEL. I hope I will be making more series as time progresses. So if you are yet to be a member of this channel or a subscriber or a follower of this channel, do well to hit the subscribe button and then turn on the notification bell by the side in order for you to get notified when I upload new videos. All right, thanks for watching, and make sure you share this video to your friends so as for them to benefit as you are also benefiting. So wait for more videos to come.